Let's look at an op amp question where we need to find a number of currents and the output voltage. It's a negative feedback configuration. What this means is that V minus is going to be V plus as long as op amp is in linear regime. This means it is not saturated. So let's identify the voltages that we already know in the circuit. This is our reference here. So we know this is 0 volts. Let's put this node at 0 volts. This is 0 volts. This is 1 volt. There is no current running into the positive terminal of the op amp, so this also becomes 1 volt. So we already know what I2 is. I2 is 0. We know this voltage here. It is 5 volts. If the op amp is not saturated, we know what this voltage is going to be. This is 1 volt. So in order to calculate I1 and IF, we can just write our node voltage expression. We can get I1 from using Ohm's law, because this current here is I1. So I1 equals to 5 volts minus 1 volt divided by 1 kilo ohm, that is equal to 4 milliamps. 4 milliamps. And we know that there is no current running into the input terminal of the op amp. Therefore, I1 plus IF equals to 0. This makes IF equal to minus 4 milliamps. Minus 4 milliamps. If you know IF, then you can also calculate V out, right? We have IF equals to V out minus 1 volt divided by 10 kilo ohms. This is our Ohm's law. So that means minus 4 milliamps times 10 kilo ohms plus 1 volt equals V out. So this means V out equals to what does minus 4 times 10 kilo ohms mean? Minus 40 volts plus 1, that makes minus 39 volts. The op amp is powered with 20 and minus 20 volts. So this shows that we are in saturation, negative saturation. So V out is really saturated at minus 20 volts. So V out is minus 20 volts. And now we have a problem here because our assumptions for the V plus equals to V minus is no longer valid. So we can really not rely on any of these values anymore. So these are really I1 is still, R1 is unreliable, so we cannot rely on this. I2 is 0, this is correct, because this doesn't change the saturation condition or not. And this is no longer reliable, so we cannot look at this. So we need to now go back and calculate IF, I1 based on the V out value. So now V out value is known, so it is minus 20 volts. If this is minus 20 volts, the current that runs through the 10 kilo ohms and the 1 kilo ohm is continuous, we can just write IF times 10 kilo ohms plus 1 kilo ohms equals to minus 20 volts minus 5 volts. So IF equals to minus 25 volts divided by 11 kilo ohms. If you know IF, you know what I1 is. I1 is going to be equal to negative that. So it is going to be 25 over 11 milliamps. If we know V out, can we calculate the load current IL? IL here equals to V out minus 0 volts divided by 10 ohms. So that is equal to minus 20 volts divided by 10 ohms. That is equal to minus 2 amps. If we know IL and IF, can we calculate I naught? We can. I naught equals to IL plus IF. And I think we have calculated everything in here using these values.